Alright, ladies and gentlemen, welcome to the third and final video for section 8-6, which covers law of sines, law of cosines. This last little piece here is kind of just a cool thing that I am requiring my geometry students to know, and that is how to find the area of a triangle when you are given all three side lengths. That can be done very simply by referencing a new vocabulary word and a new theorem. So the new vocabulary word is the semi-perimeter. Semi-perimeter is half the perimeter of a polygon. Half the perimeter. Okay, so Herrons' formula for area of a triangle. Again, this is a rule we are going to use, so it should be in green in your notes so that you can look it up. It does require SSS information, all three sides to be given. If S is the semi-perimeter of triangle ABC, as shown, meaning that S would be 1/2 of the perimeter, which would be little a plus little b plus little c, then the area of the triangle can be given by Herrons' formula, which says that the area of the triangle is equal to the square root of the product of the semi-perimeter and the difference of each of the side lengths with the semi-perimeter. The square root of S times S minus A times S minus B times S minus C. Now again, that's A, which is one of the side lengths, B, which is one of the side lengths, and C, which is one of the side lengths. And then we first find the semi-perimeter, S, and then we turn around and we plug those numbers into this area formula. So this is a two-step process. Step one is to find the semi-perimeter, which is the sum of all three sides, A, B, and C, added together and divided by 2, or 1/2 times the sum of A, B, and C. And then we're going to plug that S into the area of the triangle. So then we will find the area of the triangle using Herrons' formula, which says square root of S times S minus A times S minus B times S minus C. And again, that's the S from step one is going into that thing 4 times, once by itself, and then once with each of our 3 side lengths being subtracted from it. So let's do some example problems using Herrons' formula. Here we go. All right, so first up, we have a triangle QMP, which means 3 would be little q, 8 would be little m, 6 would be little p. Now, if you've watched the previous videos, this picture should look familiar. It was what we used in the last one to find angle M. So step one, we find the semi-perimeter. That would be 1/2 of P plus Q plus M. So the semi-perimeter would be 1/2 of 6 plus 3 plus 8, or 17/2. That's a fun number. You could also go ahead and use the decimal 8.5. And in terms of writing out the Herrons' formula, if it's a nice decimal, which it should always be a pretty nice decimal unless the side lengths themselves are decimals, you should probably use the decimal here. Okay? Now again, what did we do? We added up our 3 side lengths, P, Q, and M, and then we divided by 2. We did 1/2 of that. That gives us our semi-perimeter S. Step 2 is then to find the area of the triangle. In this case, we would take the square root of the semi-perimeter times the semi-perimeter minus P times the semi-perimeter minus Q times the semi-perimeter minus M. So that would be the square root of 8.5 times 8.5 minus 6 times 8.5 minus 3 times 8.5 minus 8. And when we multiply that out, we're just feeding it to our calculator exactly like it is written. Type it in very carefully. Make sure that you do not close the square root until after everything is typed in. And it should spit out the area of the triangle. So the area of the triangle would be 7.64. That next digit is a 4. We don't care about anything after that because we are rounding to the nearest hundredth. So the area of the triangle would be 7.64 square feet are my units. Okay, on to the next example. Again, if you need to, you can pause at any time. So here we have 3 side lengths, little u, little v, and little w. We are being asked to find the area. So first we find the semi-perimeter. Remember, that is 1/2 the sum of the 3 side lengths. It doesn't matter what letters are being used for the 3 side lengths. We just plug in those numbers, we add them up, and we divide by 2. So that would be 1/2 50 plus 61 plus 29 means that the semi-perimeter is 70. Then we turn around and we find the area of the triangle using Herrons' formula, which is the square root of s times s minus u times s minus v times s minus w. So again, that 70 is getting plugged in for all 4 s's. U is 50, v is 61, and w is 29. So we're looking at the area of the triangle is the square root of 70 times 70 minus 50 times 70 minus 61 times 70 minus 29. If we're careful and we feed that into our calculator, all we have to do is type that in, and our calculator will spit out that the area of the triangle is 718.748. And it does keep going, but we don't care because we're rounding to the nearest hundredth. That 8 tells us that we should round our answer up to 718.75 square units because we do not know whether it's inches, centimeters, etc. 2 examples to go. This next one will seem like it's the hardest because we have decimals. Again, it's not any harder. We have 3 side lengths which are named based on the opposites from their angles. Step 1, we're going to find the semi-perimeter. Remember that to find the semi-perimeter, we're going to do 1/2 the sum of those 3 sides, j, k, and m. So we take the j, which is 1.9, the k, which is 1.3, the m, which is 2.1. We add them up, and we divide by 2. So the semi-perimeter would be 1/2 of 1.9 plus 1.3 plus 2.1. We add those up, we divide by 2, we get a semi-perimeter of 2.65. Not our best number ever, but it is absolutely accurate, so let's run with it. So next we're going to find the area of the triangle. Again, we're using Herrons' formula, which in this case would be s times s minus j times s minus k times s minus m. So that would be the square root of 2.65 times 2.65 minus 1.9 times 2.65 minus 1.3 times 2.65 minus 2.1. Again, be very careful. Type that in your calculator. That's a lot of things to type in, so take your time. Make sure you type it in correctly. You should get that the area of the triangle is 1.214. Again, we don't care about any digits past that 4 because we're supposed to round to the nearest hundredth. A 4 means that we're going to leave the 1 alone. We're going to round down. And our answer would be 1.21 square millimeters. On to the final example in the notes. Little r, little t, little s. Again, step 1. Find the semi-perimeter, which is 1/2 the sum of the 3 sides, r, s, and t. It does not matter which order you write them in. You need to add them up, and you need to divide by 2. So, that means that s is 1/2 of 3 plus 6.1 plus 4.5. So s is 6.8. Again, you add them up, divide by 2. That is going to be our s value. We are then going to find the area of the triangle using Herrons' formula. Semi-perimeter times semi-perimeter minus the side length s. Oof, I don't like that very much. Okay? Semi-perimeter minus r, semi-perimeter minus t. Now again, I don't love that there are 2 s's in there, but they are different s's. The first s here is the semi-perimeter, like in all the other problems. And then we've got r, s, and t being subtracted from that semi-perimeter. So the area of the triangle is the square root of 6.8 times 6.8 minus 6.1 times 6.8 minus 3 times 6.8 minus 4.5. And it doesn't matter which order you put r, s, and t, the side lengths, into Herrons' formula, as long as you use each one exactly 1 time. Again, carefully type that in, and we get that the area is approximately 6.449, which we would round up to 6.45, and our units are square yards. There we go. That's it for 8-6. Thank you very much for your time and attention.